now. So, ayun. Magandang hapon sa inyong lahat. So, for week 2, ang ating topic ay Big O and algorithm complexity. So, actually, those are two different things. Big O is what we use to represent yung tinatawag na algorithm complexity. Ang level ko. Parang kung wala nasa class tayo. May class para di nakaharap. So, anyway, yun. Okay, so for the week 2 sa study guide, meron dalawang activities over here. First is yung big O notation and sample algorithms sa sorting algorithms part. Okay lang ang audio ko, hindi masyado mahina. Since, okay naman ba? Earlier this week kasi meron problems ako sa audio. Okay. So, okay na. So, may handout Sir Marcos dito. Pero yun, medyo I guess pag dinaanan natin sa page per page, medyo matagal. Meron kasi akong slide set before na medyo summarized naman na yung important parts. So, ang main topic natin is analyzing yung tawag natin time complexity. So, ang titignan natin yung ating algorithms depending on their running time with respect dun sa input size. So, of course, kung ito, meron tayong for loop na depende dun sa contents ng isang array. Pag dumadami yung contents ng array, tumatagal yung algorithm, of course, kasi dumadami yung piniprint natin. Pero, for example, ayan yung dito, for I in array. Pero pag may constant lang naman na yung first 10 lang naman yung kinukuha natin sa array, kahit maging 1 million yung ating input, kung yung first 10 lang yung kino-consider natin, yung runtime natin is hindi lumalaki masyado. So, and then eventually, magkaka-encounter din tayo ng other equation or other algorithms na instead na linear na ganito, magiging quadratic sila, n squared, or even n to the sixth. So, mahalaga kasi, ang mahirap kasi yung actual running time yung kino-compare kasi iba-iba siya per device. So, pwedeng maganda yung computer mo, so mabilis yung running time sa'yo ng program, pero pag nilipat natin sa ibang computer na medyo luma, baka hindi siya ganun ka-bilis. So, ang tinitignan natin as software engineers, kung din man kayo mapunta, is yung time complexity. So, pag nilakihan ko yung input, gaano siya kabilis bumagal, if that makes sense. So, or gaano kalaki yung change ng kanyang running time with respect sa input. So, to simplify things, kung meron tayong complex na expression ng running time, meron 6 to the 5th, to the 4th, to the cube, etc. and etc. You'll notice na pag sobrang laki naman ng input, dito nga, sa 1,000, nag-overlap na si n to the 6, tsaka yung n to the 6 plus everything else. So, ang kino-consider natin for at least 2s2122 and what is mostly used sa in practice is yung tinatawag na asymptotic behavior niya, wherein kino-consider lang natin yung fastest growing term. And actually, pati yung coefficient nga hindi na natin pinapansin. Kasi, kung meron tayong 2n squared at saka n squared, lalo na pag lumaki yung input size, pareho lang naman yung kanilang behavior. So, and sinusunod natin yung asymptotic behavior. And then there are different types of asymptotes. Kasi pwede kang, yung asymptote mo pwedeng upper limit siya, yung asymptote mo pwedeng lower limit siya. So, ang i-consider natin yung tinatawag na worst case na asymptote or yung worst case analysis, big O. So, yung other examples ng analysis is yung best case, siya yung lower bound. Pero yun nga, yung best case naman natin, hindi naman natin siya kayang i-expect na laging nangyari. So, parang wala siyang masyadong use. Yung worst case naman natin, at least alam na natin yung pinakamabagal na pwedeng mangyari. So, if prepared ka for the worst, kahit dumating yung best, okay ka lang. So actually, although average case yung usually nagmamatter talaga in practice, mahirap siyang i-identify. So hindi natin siya isasama dun sa scope ng 11121. Although, ayun, ang worst case naman is a very good metric naman pa rin overall. So yun, big O notation, pwede siyang gamitin for time complexity and space complexity. Ang focus natin for the week ay yung time complexity muna. So, yung running time. So, yung mga big O, usually, since yung fastest growing term yung kino-consider natin and hindi natin kino-consider yung mga coefficient. So, parang meron lang certain set of terms or expressions na ginagamit for representing yung big O. So here are the most common ones. So pinakamabilis sa atin yung constant O of 1. And then next is yung logarithmic O of log n. And then linear O of n, log linear, and log n. And then we have quadratic, n squared, polynomial, yun yung mga n cubed, n to the fourth, n to the fifth. And then yung to the n, and then n factorial. So usually, yung mga n factorial, yung input natin kahit maliit pa lang, sobrang bagal na kasi medyo horrible yung ano ng time complexity. So as much as you can, ang actually most ng implementations na pupunta dito sa n log n region. So paano natin ina-analyze yung ating big O? Well, and time complexity in general for our algorithms. So for basic operations, read and write, addition, assignment, addition, subtraction, multiplication, division, most of the time are constant O of 1. So, pag sequential, they add up. So, kung meron tayong tatlong operations, one after the other, sequential, mag-add lang. O of 1 plus O of 1 plus O of 1 is O of 3, pero di ba nga hindi nagmamatter ang coefficient sa atin, so it's still O of 1. So if napapadpad kayo sa mga programming memes, gano'n, yung mga programmers, pag tinanong mo sila what is O of 1 plus O of 1, ang sagot ay O of 1, hindi O of 3. And then we have conditional statements. So recall, ang ginagamit natin is yung worst case na time complexity. So whichever yung mas complex sa dalawang branches, kung si if ba yung mas malaki or si else, siya yung magmamatter. And i-add natin siya dun sa complexity ng pagtitest. So regardless if true or false si test, i-execute mo pa rin siya. So kasama siya, O of test. And then, i-add natin complexity ng dalawang body, whichever yung mas malaki. Kasi, yung mas malaki yung magmamatter. Then, if we have loop, usually, yung form niya is ganito. Yung complexity nung nasa loob times yung number of iterations. So, kung yung dito sa loob is a constant operation, and then, ayun, yung isang loop na to runs for n times. So n times 1. And then ito naman sa labas is n times 1. So may n squared. Then, ayun, and a couple of properties. Suppose meron tayong t of n at saka s of n. And then yung mga big O nila is si f of n and si g of n. So pag si t of n at saka si s of n, ginawa natin ng magkasunod, may kita natin na yung equivalent na big O is whichever is yung higher sa kanilang dalawa. And then if i-multiply natin si t of n kay s of n, i-multiply lang natin si f of n at saka si g of n. So yun, interpretation, we get the fastest growing term. And then we can multiply them when they are used in nested for loops, tsaka recursive functions. Yeah, so may example dito. We have basically nested na for loop. Yung sa loob of 1. And then yung dito sa gitna actually is for k in the range of j. And then si j ay from yung range ng I, and then si I is sa range ng n. So, ilan yung total number of iterations dito? So, ayan, it depends sa number ni j. So, ano ba yung number ni j? It starts at 0, and then 1, and then 2, and then 3. So, para mag-add up yun, so 1 plus 2 plus 3 plus 4 hanggang I, ang makukuha nyo actually dito is of I times I. So, I squared, and then makukuha nyo dito, kasi j will be approximately I pag malaki na siya. And then, ganun din, si I is approximately n pag malaki na naman na yung mga numbers. So, may n cube. So, actually medyo nag-skip ng konting steps kasi medyo ito na yung nasa mahirap na end ng pag-analyze. And I actually have more simple examples over here na actually, since sinagutan na namin nun sa earlier class, try ko open at ito, wala pa yung ito sa dulo. Okay. So, for example, ito si function 1, yung simplest case, we have a sum na nag-add lang, so constant, and then for a certain amount of iterations depending on x. So, for I in range x means na x times mo siya gagawin. So, x times mo gagawin, yun isang O of 1 na operation, it's an O of x na operation. And then, ayun, meron O of 1 na sum, and then O of x na operation, and then O of 1 sa dulo, and na-add up lang natin sila. So essentially, since sa Python, naka-same tab naman yung mga magkaka-level, basically, alam mo kung alin yung i-add. So, yung malaking indent, siya mag-isa. Pag nagtanggal ka ng indent, usually mag-multiply ka. And then, pag magkakasing indent, i-add lang natin sila, O of 1, O of x, and O of 1. And then, for some people, ang nauuna sa kanila is yung outermost na for loop. Ako, mas gusto ko yung sa innermost. Later on, pagka meron lang mas madaming naman. Okay, so si function 1 is O of x. Next, we have function 2 na instead of range x, it's range 100. So, yung nasa loob pareho lang, so it's still O of 1, but we do it 100 times. So, 100 times O of 1 is still O of 1 kasi, di ba, hindi nga nagmamatter yung coefficients sa atin. Pag multiply lang, hindi siya, we don't really care about it. So, yung tatlong magkaka-level natin dito, yung sum, yung for loop, and yung return, pareho daw silang O of 1. So, ang complexity ni function 2 is O of 1 pa rin. Although, for example, si x is 10. So, pag si function 1, pag x is 10, 10 times uulit yung loop. Pero si function 2, pag si x ay 10, 100 times uulit si loop. So, sino yung mas matagal magra-run yun? Si function 2. But, mas malaki yung complexity ni function 1. Kasi, if lumaki pa lalo yung input natin, for example, nasa 1 million, ito, magra-run 1 million times. Ito is magra-run 100 times pa rin. So, yun yung isa sa mga caveats ng asymptotic analysis natin. It's only true, or yung comparison natin ng running time is only true pag malaki yung input. So, we have to be clear when we actually refer to the time complexity or the running time. So, time complexity, ito yung discuss natin ngayon, yung big O. And yung running time is yung actual na running time niya. If tinry mo na siyang lagyan ng actual inputs. And okay, so moving on, dito tayo sa function 3. Almost same sa function 1 except that yung ina-add natin dito is actually the result of a function. So, ano yung running time or ano yung time complexity ng line na to? So, it's the addition operation plus the time it takes for us to compute or to run yung function 1 of x. So, yung big O ni function 1 plus yung big O ng addition, which is just constant. But we know yung big O ni function 1 is just O of x. So, this can stay. We can simplify this to O of x. So, yung O of x na nasa loob, ay multiply natin ng x times kasi nasa loob ng loop. So, we get O of x squared. And then si O of x squared is naka-add siya kay sum, tsaka yung kay return. So, we have an overall function 3 na O of x squared. Okay. So, what if gawin ko to x times x? So, yung mangyayari dito, yung big O ni x times x or big O ni x squared. So, since x squared yung input natin kay function x, ano yung magiging complexity niya? Hindi na siya hanggang O of x lang, magiging O of x squared siya. So, ito yung mga simula na nung pagiging medyo nakakalito. So, since x squared yung input, we can, siguro, kunwari, gamit tayong ibang variable, n. We use n squared. Or, hindi, sige, sabihin natin we use n. So, ano yung running time ni function 1 pag n yung input? Or yung time complexity niya, it will be n. But if I assign n equals x times x, ito is ma-replace na x. Well, ito is effectively x times x. So, magiging big O of x times x siya, which is x squared. So, ayun. So, nagde-depend pa siya dun sa input natin dun sa function. And hindi lang siya completely dependent doon sa time complexity ni function. So, parang kung minodify natin yung nasa loob, mag-iiba yung overall na time complexity niya. Nasundan yun? Doon usually nagkakaroon ng confusion. Next is we have function 4. So similar siya dun sa original na function 3, except that yung sa x dito ginawa siyang I. So yung time complexity nung nasa loob is dependent dun sa value I. So tinanggal ko lang yung xn kasi nakakahaba siya ng konti. Pero I hope okay lang. Hindi naman siya nakalito. So iulitin natin siya for x times. But for each time na ulitin natin, iba yung actual na time na ina-add niya. So what we can do is instead na gamitin yung straightforward na multiplication, pwede natin siyang isa-isahin. So starting from big O ni f1 of 0, big O ni f1 evaluated at 1, so on and so forth hanggang n minus 2 at saka n minus 1. So if i-apply natin yung big O rules natin, kailangan lang natin yung highest growing term. So, pwede kong tanggalin si n minus 1 at saka si minus 2 at saka si minus 1. And then yung mga nandito, pwede silang maging n lang. I guess, meron tayong nag-skip tayo ng konting step kasi yung big O ni f of 1 is just f of x. Di ba? So, it's as if big O ni n minus 1 to. And then ito is big N ni n minus 2. And ito is big O of 0. And then ito is big O of 1. Nakuha naman yung transition natin doon. So, Assuming pag hindi kayo nag-react. So, pwede natin tanggalin si n-1 and si n-2. And then we're stuck with, so, pag nag-add tayo ng O of n plus O of n, technically, di ba O of n yun? Pero that is for a constant coefficient. Pero ilan ba yung n na ina-add up natin? Actually, hindi tayo sure. Kasi nag-start to from 0 to n. Kailan tayo magsa-start? Kasi kung ginawa kong x equals 10, kung gawin ko tong 9, ay gawin ko tong 8, gawin ko tong 9, naging constant sila. So parang hindi siya hindi to mukhang magandang direction para ma-simplify siya. So we can go back doon sa naka n-2 tsaka n-1 siya. And then pwede naman natin i-add diretso. So wag tayong dumiretso, wag tayong mag-shortcut at i-simplify yung nasa loob ng big O. Let's add all the intermediate steps first. So starting from 0, plus 1, plus 2, plus dot, hanggang n-2, tsaka n-1. So what you'll notice here that this is a arithmetic series. So sum ng 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, wherein yung total na makukuha natin is actually big O of sum nung first and last na digits, n-1 minus 0, and then i-multiply natin siya with the total number of digits na ina natin. So n-1, since hanggang 0 siya, may plus 1 yun, n-1 plus 1 all over 2. Kung ganito lang yung ating expression, this would be from maging n tapos maging n-1 yan, diba? Kaso may 0. So, to account for yung 0, ganyan siya. So ito is just n over 2 times n-1. And then, dito na natin pwedeng i-apply yung ating simplifications. So, ating coefficients, we can disregard. So, we can disregard yung 2. And then, we can disregard yung constant na term na hindi masyadong mahalaga. And we are left with O of n squared. And nagkamali pa pala ako dito kasi ginawa ko n. This should be x. Tama ba? But the analysis is the same. Nag-iba lang ako ng letter. So, ayun. So, this loop, na kahit na hindi naman siya O of x yung nasa loob, O of I siya, yun pa rin yung makuha natin. Result, O of x squared. And medyo nagpa-follow through yun kahit let's say ito is instead of maging O of I siya, di ba? Pag naging O of I squared to, this will eventually be maging O of x cubed. If naging I cubed to, ito yung maging x to the 4th. So para lang siyang kasi kung tutusin, at the worst case, I would be extremely large na almost equal to x. So, yung I cube na inulit-ulit natin x times is almost equivalent to x cube na term. So, ayan. Medyo mahabang explanation pero I think yung simplification, pag meron kang loop na ganito, na kahit hindi x O of x yung nasa loob, if O of I siya and then I yung nag-iterate, you can simplify na agad na O of x squared siya. And then, moving on, for function 5, we have this. So yung sum natin, mas madali na ngayon, hindi na siya function, it's just plus 1. But What's different here, yung nasa range natin is function, yung nasa loob. So this is the same as storing mo muna sa isang variable yung value ni function tree and gagamitin yung variable na yun doon sa loob ng range. So, excuse me. This one, ang time complexity nito is O of function 3 of x, which is, balikan lang natin, since x lang din naman yung input, O of x squared. Then, dito naman sa for loop, meron tayong O of 1 sa loob, and then range t. Pero ano yung value ni t? So, ilang beses natin siya uulitin. So, actually, yan. Ang magiging runtime or yung time complexity ng ating for loop over here will be t, the number of iterations, times O of 1. Or simply O of t. However, hindi pa tayo sure kung ano yung value ni t. So, kailangan natin instead of just analyzing yung timing ni function tree, kailangan natin i-analyze ano ba yung nire-return yung na value. So, ang nire-return yung na value is yung result ni function 1. And yung nire-return na value ni function 1 is si x, in-add mo kay sum, x times. So, sum here will be equal to x times x. Kasundan naman yan. Kasi ito, in-add ko si x kay sum, and ilang beses ko siya ulitin, x times. So, x times x yung result ni sum. Or, other words, x squared. And then here, ang ina-add ko is function 1 of x times x. So, x times x, x squared. So, gamitin natin yung change of variable natin. If this was n, ang sum natin dito ang ina-add natin pala kay sum ay function n. Right? N, function 1 of n. So pag n yung input, ang sum natin ay n squared. So yung ina-add dito ay n squared effectively. And then si n squared, ina-add natin siya to itself x times. So yung sum in total is x times n squared, but si n equal siya kay x times x. So this is x times x squared. So ang ating grand total is x squared squared. So x to the fourth. So this is x to the fifth. So si function 3, ang nire-return niya na value is yung input x to the fifth power. So hindi siya same with ating time complexity na x squared. So it just so happens na yung return value natin is related doon sa input natin na x. So going back, dito t is equal to function 3 of x. But we know si function 3 ay x to the fifth power. So yung O of t dito is magiging O of x to the 5. So yung loop natin repeats for t times and t is equal to x to the 5. So, okay. Yung ating sum, yung first operation is O of 1. Yung pag-calculate ng function is O of x squared. Yung loop natin itself is big O of x to the fifth power. And then may O of 1 tayo sa dulo. So si function 5 ay eventually x to the 5 yung kanyang complexity. Okay. Then next sa function 6, pareho siya sa function 5, except that si I, instead of element siya sa for loop, it's a counter. So I starts at 0 as long as I is less than function 3, uh, we get sum plus equals 1. And then si I nag-increment lang by 1. So, ayun, without knowing yung value ni function 3, alam dapat natin yung loop na to would iterate kung ano man yung value ni function 3 times. And ganun siya kadaming beses mag-eval. So, yun nga, ang alam natin, t is equal to function, right? Well, ito, function 3 of x is equal to x to the 5th. So, x to the 5 iterations. However, saan natin siya i-multiply? Is it just O of 1, which is yung nasa loob? So, ang difference ng for loop at saka while loop, si for loop is nag-iterate siya over a list. Si while loop, nag-check siya ng condition. So, ilang beses siya nag-check ng condition? So, mag-check siya ng condition at every iteration ng loop. So, yung time complexity nung pag-check ng condition is kailangan natin i-account doon sa time complexity ng buong loop. So, ayun, instead of just yung O of 1 dito, dadagdag natin yung time complexity ng condition, yung pag-evaluate ng condition, doon sa i-multiply natin sa number of iterations. So, this simplifies to x to the 5th times si function 3. Ang complexity ni function 3 ay x squared. Right. So, we get a grand total of x to the 7. Now, kung papansin niyo si function 5 at saka si function 6, expect mo naman pareho lang yung sum. Since effectively yung for loop, convert na natin to a while loop. However, may malaking difference tayo when it comes to the time complexity. This one is x to the, si function 5 ay, si function 5 ay x to the 5th power, and si function 6 ay x to the 7th power. So, x to the 7th power. So, dito na papasok yung ating skills. So, nakita natin na pareho lang yung ginagawa, pero ito mas mabilis over this one. Bakit? Because yung condition dito is nauulit-ulit natin doon sa for loop. So, ano yung pwede natin gawin para pabilisin siya? So, kailangan labas natin siya sa for loop, lalo na hindi naman nagbabago yung value niya. So, we can assign a temporary variable t dito sa nandun, and lagay na natin yung t dyan. And just by doing so, mapapababa natin yung expression, or well, ito, ang pag-calculate ng function 3, lalabas lang siya here. Pero huwag kalimutan ilipat dito. So this will become x to the 5th power. And then dito is O x squared. So instead of multiplying them, gawin na lang natin silang, instead of pag-multiply sila sa isa't isa, we just add them in this case. So hindi masyado nakaka-affect yung time complexity ng pagkuha ng limit ng ating loop. So, parang yun, by being aware of our time complexity, we can make our own good programming practices. Tulad ng ganyan na kung meron kang ine-evaluate na function na hindi constant, make sure na hindi siya nakapasok sa loob ng for loop kung pwede. So, for example, ito, si function 3, ito, of course, pwede ko siyang ilabas and kaya kong ipababa yung time complexity nito. However, dito sa function 4, requirement na yung I, siya yung nandun sa input. So, hindi ko may iwasan na ilagay siya sa labas. So, ayun lang. So, may limitation din siya. But, I guess that's one of the few things you can do pagka ganyan yung situation. Okay, so tapos na tayo sa function 6. Let's have function 7. Function 7 naman, relatively simpler. Wala tayong additional na functions na ginamit. But, ito, nagka-count from 0 plus 1 plus 1 plus 1. Ito is nag-start from 1, tapos nag-times 2 and nag-times 2 ng nag-times 2. So, well, madali lang naman ito. Pareho lang naman silang constant time. And for sure, constant lang yung sa loob ng while loop. Ang question for us here is, ilang times nag-run yung loop? So, siguro let's just tabulate yung value ni I. So, let's say number of times mag-run yung loop. Or, ginamit ko kanina is iterations. Kaso ang haba. Bibili na siguro akong drawing tablet. Pagka wala pang iteration, 0, ang ating I ay 1. So let's just assume first na x equals infinity. So hindi tayo titigil. So after 1 iteration, our I is equal to 2. After 2 iterations, ang I natin is 2 times 2, 4. And then the next one, 3, we have 8. We have the next iteration na 4, we have 16. And actually, you can predict if iterations equals a random number n, ang I natin will result in 2 to the n. Sundan? Nagets naman yun, di ba? Kasi ito is 2 to the 0. This is 2 squared. This is 2 cubed. This is 2 to the 4. So yun, yung number of iterations natin, n, corresponds to the I value na 2 to the n. So if we want to have n iterations, ano dapat yung value ni x? So x should be greater than 2 to the n. Or equal to, pwede rin. Parang mali. X. 2 to the n is less than or equal to x. Pero less than or equal to 2 to the n plus 1. Okay. Wala yun. Wala equals na yun. Pero in any case, given any value x, let's say sakto, if I have the value x, ilang runs yung makukuha ko? So if x is equals to 2 to the n yung number of iterations, ano yung number of iterations natin? So may log base 2 of x, hindi ko din nilagay yun, equals n. So ito yung number of iterations. Nakuha ba? So what we replace over here, log base 2 of x. Kasundan. Now, you may be wondering, yung sa tables natin kanina, or yung sa expressions natin kanina, wala tayong log base 2 of n. Meron na tayong log of n. So, pwede ba log of n na lang yung gamitin ko? So, recall, log base 2 of x equal lang yan sa log x na base 10 over, ba't hindi ako consistent? Log 2. And si log 2, this is just some constant c. So I can actually just use log of x as my big O function. So log x. So log of x iterations times O of 1, we get a total of, big O of log x. Okay? Okay. 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 Apat na lang. Ano? Bago pa. Mas mabilis ako. Hopefully, nakakasunod pa rin kayo. Mas mabilis ako ngayon, pero nakakasunod pa naman. We have function 8. So, parang similar story. Kinombine natin si function 7, si function 6. So, nandito si function 3, nandito si function 7, and then we have times equals 2 na counter. So, we already know si function 7 ay O of log x. And then, so this while loop, ang number of iterations niya, ay, hindi siya log x. So, we can O of log of function 3 of x. Tama ba? And then, ilan yung number of iterations ito? Hindi, joke lang. I'm mistaken. This is just O of log x. So, wala naman palang bago dito. Yung number of iterations, yung question mark. So, let's say n muna yun. N iterations times O of log x. So, let's look for a value for n. So, n is supposed to be yung function 3 na value. Pero, hindi siya direct conversion kasi naka times equals 2 tayo dito. So, para lang ginawa natin na t is equal to function 3. And di ba nga dito, log x yung number of iterations natin. So we can say here na yung number of iterations natin is log of t. And then t, we know that as si function 3, balikan lang natin. Ang kanyang result ay x to the 5th power. So, x to the 5th power. So, yung ating log of x to the 5, kung familiar pa kayo sa logarithms, that's just 5 times. So, let's just replace yung n over here. Five times log of x times log of x. So that is big O of log squared. Si log yung squared, si x yung isa lang. So yung 5 na coefficient is just a constant term. So, wala to sa yung mga usual. Pero it's also a valid na expression for big O. Pero madalaw lang kasi siya mangyari. Log squared of x. Then of course, oh, we forgot something. So, while loop kasi to, di ba? So, again, si function 3 may evaluate every time mag-repeat yung loop. So, instead of just O of log x over here, we have O of log x plus yung time complexity ni function 3, which is O of x squared. O of x squared. So, paggalawin natin ito. So, and so O of x squared, which is much more greater than O of log x. So, ang matitira lang dito yung term na yun, and then we multiply it with log x. So, it will be x squared log x. So, pwede natin tanggalin yung 5 because that's just a constant na coefficient. So, big O of x squared log x. So, para siyang log linear pero quadratic, log quadratic. Yeah. It's not very common pero ayun, yun yung nakuha natin result. So, medyo hindi na natin pinapansin yung mga constant sa labas kasi, sanay na tayo. So, this is O of O of x squared log x. Now, ayun, ito medyo mas madali na ulit. So, we have sa innermost na for loop, we have O of 1. And then this one, we have x times O of 1. O of x. Then this one, we have x times, excuse me, O of x. So we have O of x squared. Then, kahit di ko na siguro pakita, this is O of x cubed. So eventually, our function is just x. Simple lang. Mas mahirap pa yung nasa slides. Yeah. Then for function 10, ganito yung nasa slides actually. So yun nga, since linear naman, I mean, I is from 0, 1, 2, 3, 4, 5, wala tayong split na numbers, we can assume, yun nga, j is approximately I, and I is approximately x. So, parang ganun din. So, this one is O of 1, which makes the loop big O of x. This one is x squared, and then this one is O of x. So, hirapan naman natin dito sa function 11. So, medyo mas marami tayong mga loops over here. So, ako, ang preference ko is start from the most inner na statement. So, some kasi gusto mag-start from the outside. So, kunin yung number of iterations and then calculate for the O of 1 nito. And then, parang nested na variables muna. So, what I do is nagsa-start ako dito sa pinaka-konti, I mean, pinaka-innermost. So, wala namang mas mabilis. Nasa preference mo lang talaga yon as a person. So, ito, we have yung dagdagan natin yung tabs para we have the time complexity of function 2 of x. And recall, si function 2, siya yung constant natin over here. So, this is just O of 1. And then, ayun, this loop naman, number of iterations niya is x, and we multiply it with O of 1. So we get O of x. Then this next loop, yung sa innermost niya is a function 3, O of function 3. Hindi nyo pa kabisado, this is x squared, di ba? Wari kabisado, di ba? X squared. So here, the loop iterates for x times. So we have x times big O of x squared. So medyo loose naman tayo dun sa kung saan merong big O and kung saan wala. Usually pag number of iterations, prefer ko na hindi siya ilagay sa big O kasi hindi naman talaga siya binibig O. Ito lang yung binig O natin. Ito hindi pa siya na big O. Hopefully, nasunod yun. So basically, it's just kung saan naman natin na-apply yung mga asymptotic na assumptions. So si x dito, wala pang assumptions na na-apply sa kanya. So it can remain as is. Okay, so we have two loops. Yung isa O of x, yung isa O of x cubed. And then we have another one here, na function. Naka-level niya. And big O ni function 1, unang-una, is just O of x, if you recall. So our outermost loop is just the addition, well, the number of iterations, x. And kaya ko rin hindi nilalagyan ng big O kasi para ma-differentiate mo. Pag wala pa siyang big O, it usually means kung ilang iterations. So we add yung mga ginawa natin sa loop, which is O of x, and then O of x plus O of x cubed. So, para bigay mo nito, this one corresponds to this one, and then this one is this one, this one is this one. So lahat sila is yung magkaka-level natin dito, di ba? And kung expert na kayo actually, you know na, okay, O of x to, O of x to, ito x cubed. Hindi ko na kailangan pansinin itong dalawa. And I can just write O of x cubed. And that's x, which is O of x to the third. Now, what does it mean if pumangari yung algorithm na ginagawa nyo, ganyan yung itsura? It just means na kahit pagandahin ko si function 1, kahit pagandahin ko si function 2, itong loop ko na to yung nagko-contribute ng biggest complexity. So siya dapat yung itry kong i-optimize. Kasi kahit maging constant to, hindi naman siya nag-a-affect ng time complexity ko at bigger inputs, yung running time ko would have roughly the same magnitude. So, ayun. So, if, for example, gusto mo i-optimize yung code mo, hinahanap mo, paano mo siya gustong pabilisin, hanapin mo to. Ayun, nakita ko si function 3, siya yung biggest contribution do sa complexity. Okay, nakita tayo. Last example. So we have multiple loops and then medyo nakahiwalay lang yung mga naka-same level pero hindi sila loop, function lang. Ayun, start tayo with the innermost na loop. So it's just yung time complexity, the function 1, which is O of x. And then we repeat it and x times. So we get O of x squared. But ayun, ang gusto ko nga ginagawa, medyo same levels. So pasok ka dito, labas ka, and then yung ka sa next na same level. Then this one is O of 1. function 2 is O of 1. So, ayun, at this level, pwede na natin siyang i-disregard actually. So, x times big O of x squared. So, hindi na natin kinonsider to. So, when we compare this one and this one doesn't matter. So, we just use this one over here. And then, ito ay O of x cubed. And then, ito, yung ka-level niya si function 3, which is big O ng x squared. Big O ng x squared. So, and similarly, we have an x cubed term, we have an x squared term. So this one will become irrelevant. So we can just go ahead and multiply x to big O of x cubed which is equal to big O x to the 4. Tama? Then lastly, meron pa tayo dito sa baba, function 11, which is yung kaka-discuss lang natin dito, which is a big O ng x to the 4th. And then, so we have two x to the 4th terms here. So, kahit x to the 4th plus x to the 4th is just x to the 4th. So, something to notice here, say, in-improve ko si function 1, napababa ko yung complexity ng mga loops ko. Although meron pa pala akong isang malaking sobrang bagay na function sa labas. So, kahit anong optimization mo sa loop mo over here, hindi gaganda yung time complexity mo kasi meron kang isang malaking function dyan. So, ayun lang. So, yeah, so that is time complexity analysis. So, may questions ba regarding those? May nakakalito ba sa ginawa ko? So, pagka kayo na yung nagsasolve tsaka dito. Okay, well, moving on, hindi na actually yung topic for the week. We also cover yung ating sorting algorithms. So, meron ding handouts dito, pero ako mas gusto ko siyang nakikita. So, may sinend ako link sa Discord natin about the sorting sa THYZ2algo.net. So, actually, meron din siyang parang slides dito na pwede nyo ring sundan. But, pwede siya i-close para makapag-sort na kayo. And so, we have bubble, selection, insertion. So, insertion ata yung pinakamadaling i-describe si selection sort. So, as the name implies, in order to sort our list, isa-select natin yung either minimum or maximum. Tapos lalagay natin siya sa left or right. So yung nandito sa Visual Algo, I think sineselect niya yung minimum. So hahanapin niya yung minimum na element, which is yung red, and ilalagay niya sa umpisa. And then hahanapin niya yung next na minimum element. And then, so on and so forth. So, ayun, basically, ang point naman dito is ma-apply natin yung algorithm analysis natin. So, in here, we have two nested na for loops. So, we can start dito sa gitna. So, naka-pseudo code to, pero medyo malapit naman na siya sa Python. Diba? Yung set is just an assignment operation. Pero yan, titingnan natin yung for loop. Yung sa gitna is just a comparison. So, ito is, pareho naman silang O of 1. And then, we repeat the loop for each unsorted na element. So, yung unsorted na element natin, it goes from 0 to n. So we can say na this is at most n times. So n times of 1, which is of n. And then we repeat it for the number of elements. Kasi if makahanap ka ng 10 minimum, yung pang 10th na minimum dun sa 10 item list mo, na-sort mo na lahat. So, yung O of n natin dito is mamumultiply natin lang. Mamumultiply natin lang O. So, ang selection sort ay O of n squared. So, medyo binibilisan ko ng konti kasi, well, nakaisang oras na tayo. Pero yun nga, yung sa mga videos naman ni Sir Marcos, alam ko mas detailed yung analysis. Pero eventually, makukuha nyo rin yung same result of n squared siya. Then, tapos siya mag-sort. So, di ba medyo mabagal? Si insertion sort, parang in a way similar. Pero what it does is, ayun, we assume na sorted na yung leftmost elements natin. Kasi starting from one element, pag meron akong one element na list, sorted naman na siya. And then we get the next one and insert it to our sorted na list. So si 7, insert ko siya kay 37. Hindi pa siya list right now, so hindi pa obvious, pero insert ko siya before 37. So si 20 naman, insert ko siya dun sa sorted list. So it will go in between 7 and 37. And then next is 9. So it will go between 7 and 20. And then si 12, it will go between 9 and 20. So paano ko malalaman kung saan siya ilalagay? Since alam ko na sorted na yung list, hindi siya effective sa 49. Sa 20 tayo ulit. Okay. So since alam ko na sorted na to, the moment na makakita ako ng element na mas maliit kay 20, doon ko na siya dapat ipasok. So, nakita ko si 49 mas malaki, so hindi ko muna yung papasok. Si 47 malaki, hindi muna. 37 malaki. Si 20 equal, so pwede ko na ipasok or insert si 20. So, ulit-ulit lang yun. Multiple number of times. So, compared sa selection sort, yung sa selection sort, yung unsorted na elements, kino-compare natin pa sa lahat ng iba pa. And in this case, mas konti yung comparisons natin. But if titingnan natin yung complexity niya, so, excuse me, dito sa pseudocode, meron tayong dalawang for loops. And yung, of course, yung dito sa gitna, assuming yung pag-move natin is a constant operation. So this one is actually not true for every implementation ng insertion sort. If assuming this is O of 1, and then ito, yung loop natin is starts from J down to 0. So kung saan man natin siya kinuha, papunta kay 0. So if yung element natin is nasa banda dulo, that is almost equivalent to n. So this is n iterations times O of 1. So we get O of n. And then we repeat it for each unsorted element of x. Kasi notice na after each loop, isa lang yung nakukuha natin na sorted na element. So parang selection sort. After kada pasada natin, isang element lang yung nasa-store. Isang element lang yung nasa-sort. So, ayun. Kaya n times natin siya kailangan ulitin. So, if n times natin siya kailangan ulitin, yung inuulit natin is O of n. So, this is n times O of n. Assuming then na itong operation na to is O of 1. So, paumanhin sa pagsulat. So, this is O of n. squared. So, insertion sort, selection sort, and bubble sort are actually tinatawag natin n squared na sorting algorithms kasi lahat sila n squared time matatapos. Si bubble sort, nagbabubble. Notice here, yung pinakamalaking element is nagbabubble siya pataas. So para siyang selection sort, hinahanap mo yung minimum or maximum, pero nagsaswap ka na during the process. So ang ginagawa niya kasi is kino-compare niya yung first two elements, yung mas malaki lalagay niya sa kanan. And then increment siya by the next element. So lalagay niya yung mas malaki sa kanan. And then yung next element, and then yung next element, kung sino man yung nasa kanan, siya yung pinakamalaki niya na na-encounter so far. So eventually, yung maximum, nagbabubble up siya towards one end of the list. So, ayun, comparing it to bubble sort, selection sort, isa-isa natin silang ginagalaw. Si bubble sort, ayun, so may chance na hindi niya kailanganin lahat ng n times na iterations, pero at the worst case, ganun pa rin siya. Kailangan mag-bubble pataas n times or yung initial na comparisons mo hanggang n. So if malaki yung n mo, dito sa loob, mag-approach ng n. And since isang element lang yung sure tayo na sorted at a time, we know na kailangan natin ito ulitin n number of times. So naging n squared din siya overall. So, ayun, kung limited lang tayo with iterative methods or itong simple approaches na to, medyo n squared lang yung kailangan natin. N squared lang talaga yung limit. Then we have yung merge sort na preview to actually nung week 4. Sa week 4 pa siya may encounter. Kasi it uses what we call divide and conquer. So, ang ginagawa niya, gagawa muna siya ng dalawang list na sorted and i-merge na sila. And madali lang mag-merge ng dalawang list pag sorted na sila. So, ayun, essentially, kada pasada niya, kalahati ng element sorted na. So, this actually has a n log n time complexity. Although, what you can notice here, yung space sa baba, para siyang scratch work natin, di ba? So, for selection sort and selection sort nga parang wala siyang scratch na ginagamit. Si insertion sort, meron siyang konting scratch na ginagamit, pero one at a time. Pero notice here kay merge sort, gamit na gamit yung space natin sa baba. So, that is para siyang indicator na kung gusto natin medyo bilisan, kailangan natin ng more area to put our scratch work. So, ayun, medyo preview lang yun no further na topics no for EEE. So, ayun, any questions for now? Daanan lang natin mabilis yung mga assessments nyo for the week para lang may preview kayo. So we have one ungraded formative assessment. So it's ungraded pero required. So I guess pag hindi mo ito nasagutan, wala kang access sa mga quizzes na iba na graded. And you can actually preview na yun naman. It's just essay lang kung paano nyo naiintindihan yung lesson. So parang confirm lang if tama yung pagkaintindi nyo. Excuse me. And then yung actual first graded na assessment is a multiple choice na quiz sa OVLE. So ayun, sabi sa syllabus we will allow unlimited attempts pero nakalagay ngayon muna is 6 kasi we don't want to encourage yung naghuhula na lang ng sagot. So if for the first 6 attempts hindi nyo nakuha yung mga tamang sagot, I recommend na i-consult. Mag-consult muna kayo sa akin ano yung question na hindi nyo masagot ng tama. Well, actually, kahit mga 3 attempts pa lang kayo, pwede nyo nang gawin yun. Mag-consult na kayo, sir, ba't hindi ko makuha yung tamang sagot dito? Para naman alam mo kung bakit tama, kung bakit yun yung tamang sagot. Hindi yun dahil kasi lahat ng ibang choices mali. So, yun yung tamang sagot. So, ayun, if umabot kayo ng 6 attempts and hindi pa rin kayo pumasa, pwede naman kami magbigay ng additional attempts, pero yun nga, kailangan siguro natin mag-consult muna sandali para for sure yun na yung sa next attempt, makukuha mo na yung mga tamang sagot. Then, going back, yun yung first graded assessment, which is 40% of the week. The next 40% will come from yung big O problems. So parang worksheet to or parang problem set na similar doon sa ginawa natin. So meron tayong mga example code at hinanap natin yung kanilang complexity. So over here, ayan. So meron lang code. What you can do is if meron kayong ano ko sa PDF sa Adobe Acrobat, pwede kayong mag-annotate. So, pwede nyo naman sulatan lang. So, for example, this one is O of 1. This one is O of 1 din. So, pag in-add natin, O of 1, then eventually, magiging O of whatever dyan. And then, box your final answers na lang para sure kami na tama yung tinitignan na sagot. So you can annotate, you can start over on a new document. Be sure lang to label kung para sa aling problem yung sinasagutan. Kasi medyo, I guess lagay nyo na lang at least yung given para alam namin kung ano yung sinasagutan. Kasi meron talagang nagsasubmit na yung first page is yung last problem. Nasa gitna yung first problem, tapos nasa dulo yung basta para malinaw. And then, actually, dalawang part siya. Meron ditong almost essay part siya. So, meron kasi formal definition yung big O. May kita nyo yan dito sa handout. So, big O is defined here. So, I'm assuming meron kayong konting mathematical background. So, naiintindihan nyo dapat to. If not, ayun, message na lang kayo. So, ayun. So, pagka-accomplish nun, wait lang. Yeah, balikan ko yung question dun sa. So, pagkatapos nun, that's 40% and 40%. Pwede na kayo pumasa. Kahit pag ginapansin nyo yung last one. Pero ayun, the last exercise. Okay. Well, depende pala siya. Okay. So, may nagtanong, yung function po na hinahanap dyan sa problem solving is kumbari, parang O of n, O of 1 plus O of 1. Okay. So, katulad nung ginawa na natin here, part ng solution is yung pagkuha ng addition. Pero ang final answer lang natin is yung isang expression lang siya. So, if ever yung sagot nyo is a sum of multiple things, yung highest growing term lang yung kailangan yung i-box. So, for example, yung solution nyo looks something like this one. Paki-box na lang yung final answer. So, ayun. Does that answer the question? Malaki yung book ko. Find the function for the number of steps the algorithm performs. Ano lang? Mali din sinasabi ko. Okay, yung find the function for the number of steps the algorithm performs, it will be part of your solution. And yung final answer nyo is yung big O. So eventually, yung final answer na hinahanap is yung big O. Pero if hindi kayo makapag-provide nung intermediate na steps, hindi kayo makakuha ng full points. So yeah. So ang nagtanong kasi, so for example, if nakuha nyo to is O of 1, ito is O of 1, and then ito hindi ko sinasabi yung sagot ay, sige, O of n factorial, para sure hindi cancel. So, ayun, once I see this, well, ito naman na yun. Pero you can still say na yung time. So, T of n yung medyo unsimplified pa is a constant plus n factorial. Or pwede naman na rin yung naka-big O siya. Big O of 1, big O of 1, plus n factorial, big O of n factorial. So, ito na roughly itong part na to. Then you just get the final answer na O of n factorial, which is yung hinahanap dito. So, ayan siya. Yeah, so, ayan, mas close. Yeah, okay. So, ayan, ang final answer na hinahanap ko is this one. But you need to provide this one to get full points kasi kailangan yung solution. Kasi alam ko namang magaling kayo, kaya yung matahin lang, alam niyo na. Pero kailangan namin confirm yung pinagdaanan nyo. Kasi baka hindi naman sa naghihinala ko, baka hindi naman pala kayo yung nakita nyo lang pala yung sagot. So, dapat may solution. Ayan, so yung last activity for 20% nung inyong week is from yung coding exercise na wala sa hacker rank. Pero simple lang naman kasi yung instructions. So, ayan. Submit a code snippet for a function that accepts as an input a list of size n and prints all the integers from 1 up to n. So this function must have a complexity of n squared. And yun. So magpipilit na kayo 1 to n, pero kailangan yung complexity ng algorithm is n squared. So medyo baliktad siya dun sa counterintuitive siya. Pag nag-print ka from 1 to n, you'll expect na linear lang siya, pero kailangan nyo siyang pabagalin to n squared. So, ang expectation dito, pwede ba mag-print? Pwede mag-type paraan. So, for example, def yung function mo, tapos meron tayong input na array, and then dot, print, etc. So, dapat ang makita ko, for example, tapos yung array natin, may 4 na elements. So, ang expected na output here, gawin natin ibang kulay, output is yung nandun sa 1, 2, 3, and 4. So this one is yung ating output. And this one yung ating input. So hindi naman magiging strict sa format ng input and yung output kasi ang hinahanap naman dito is yung complexity na O of n squared. So, ayan. So ito yung rubric. So yung input namin is a list. Parang ganyan. So hindi siya 4. It's a list. So pwede rin siyang maging A, tapos 2, tapos 93, tapos hello. Ganun. So, basta list siya na may apat na elements. So, ayun. Madali lang naman sa Python. Kailangan. And then, yun. Ito dapat lumitaw lang only once per number. Pag may dumoble, may deduction. So, ayun. Akala ko mapagkakasya ko siya to 1. Ganun din pala. 1 hour. So, yeah, I think that's it for week 2. Any questions from the class? Any additional questions? So, I'm assuming yung mga questions dadating pagka ito na yung ginagawa niya. So, yun, these are due next week, Friday, which is March 4. Wow, March. Yeah. Okay. Ayun lamang. Next week, I don't think we'll have a synchronous session. Next week pa ulit. And medyo combined session siya with week 3 and week 4. Kasi related naman talaga sila. Actually, before 1 week lang yung week 3 and week 4. May iniwalay na naman. So, ayun. If there are no more questions, thank you for attending. And hopefully, naka-record ako. Thank you, and I'll see you around. Bye-bye.